Okay.
Yes, I do. I'll take a picture.
Go to the Chinese restaurant.
Go to the Chinese restaurant. I'm pretty sure you'll find any of
Stop being stereotypical.
Isaac, what do you think I'm gonna say?
I told him to be quiet.
Well, besides being quiet, turn. Now, knee under that. There we go. Guys, the more that you don't settle down, the more time you cost yourself to learn. So we're gonna get as far as we can through today's lesson, but if we spend a decent amount of time stopping because you're talking, less you learn. And as you learn less, at the end of the day, who suffers more? You do. So you figure it out, right? You guys are not dumb. And as I say that, I hear someone kind of humming. Now, the first thing we're gonna do is go over the quiz. The second thing we're gonna do is go over the homework, time permitting. We should have plenty of time for that. And then the third thing will be the lesson, okay? I was disappointed with how the quizzes went. I don't know if that's because it's a Monday. I don't know if it's because it's kind of rainy and dreary and bleak out and you're not sharp today. I don't know if it's because you just don't notice stuff. But I know that we gotta up our game, and we have to get better at it. That doesn't happen without your focus and your wanting to learn from your mistakes. So, first up, it says find the sum of -4 and -4.
Well, sure.
So, God bless, whatever. What's -4 plus -4? -8. Very good. Okay, so there's the first question done. Now, the next question says, gotta get the reading glasses on like this. Negative. There is a little negative sign there, it's hard to see. For whatever reason, in this class and in the previous class, the board's taken a while to warm up to the point where it reads the pen quickly. I don't know why. Number 2 says subtract -3 from -7. What's the most important word other than subtract in that entire sentence?
Negative.
No.
Oh, from.
From. What does from indicate to you?
Taking.
From goes first. Right? If I go to Montauk from Patchogue, where did I start?
Montauk. Patchogue.
Patchogue. So from always goes first. In this case, it says from -7. So it's -7, and then I subtract the -3. When I see 2 in a row, circle, agar, what's -7 plus 3?
What is other than?
It'll come. What's -7 plus 3? Guys, come on, hey, end the game. What's -7 plus 3? Everybody? -4. Okay. Next up. What operation is quotient? What operation is quotient? Division. So I'm going to do -20 divided by 5. What do you think -20 divided by 5 is? Isaac?
-4.
-4 is correct. Very good, right? We're dividing by a positive, namely the 5. So that means I keep the sign, which was negative, of the first number. Okay, next up. Use the order of operations to simplify. 8 minus 3 times 4. 8 minus 3 times 4. Now what goes first, the subtraction or the multiplication? Multiplication, so it becomes 8 minus 12, which is best read as that's a +8 and that's a -12. What's +8 and -12? -4, very good. Okay? And last but not least, right, as a series of factors, 3n to the 5th. Now there is a big difference between that and this. And in both classes, A lot of people put the answer to the red one. This exponent of 5, because it's outside the parenthesis, refers to everything inside the parenthesis, which is 3n times 3n times 3n times 3n times 3n. In other words, I didn't write the n there. It's 3n to the 5th. 3n, 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 3n. Total of 5 times. In this problem, the 5 only refers to the n. It has nothing to do with the 3. If I wanted it to have something to do with the 3, I would have to put it in parentheses. Or I could have written the little 5 next to the exponent for the 3. So this is 3 n. The only thing written as a factor 5 times is the n. So this is 3n to the 5th. Okay? Any questions? Now, my advice to you, if you want to do better on tomorrow's quiz, is to make sure that you look your quiz over between now and the quiz tomorrow, and make sure that you realize the kinds of mistakes that you made so that you don't repeat them. Okay, here are the homework answers from last night. Let me scroll through them. Excuse me. Let me scroll through these answers, and then you can see if there's any that you want to talk about. I don't have a lot of time to talk about it, but I do have a few minutes, and I would like to get that done. Okay, so we start with up here, find each sum and difference. Fundamentals right here. Any problem numbers 1 through 11? Matt, what are we talking about over there, buddy? Nothing? All right, then let me rephrase the question. Why is your head turned to the side and not looking in the front of the room? All right, well, get rid of that crick in your neck and make sure it's looking where we got to learn. All right. I don't know why this is in blue, but it's in blue. Lucky you. Okay.
Bars.
Take a look. See what you think? Yes?
For number 11, I got negative 18. That's it.
Well, no, you have to realize that negative 3 squared, you have to square the 3, then negate it. So this is negative 9. Then negative 3 in parentheses squared means negative 3 times negative 3, which is positive 9. So then I have negative 9 plus positive 9, which is 0. Okay? We got some of the from stuff going on here. We got, first you find the sum, then you subtract. We've got whether it's positive or negative. So anything up to 16 that's giving you a hard time? Anything up to number 16? Okay. Now, take a look at the next batch. Any questions here? Yes, Isaac?
Yeah, he's about to.
Actually, Jared's going to go first. Who was the one who asked for the bathroom second?
Last potty pass?
Okay. He wants it. It's his call.
You might want to call that one off, Jerry.
Jared, go ahead, go potty. Just be ready to squeeze from now on, pal.
He's probably not gonna stop going in next.
And Kimberlyn, when Jared gets back, you can go.
Okay.
Now, who just asked me a second ago?
Isaac.
Isaac did. So Isaac, you're going to be after those two.
Okay.
All right. So I guess we have the homework answers covered. And now we start talking about today's sheet. We begin with fundamentals. things that we can understand and that we can start working with and so on and so forth. Okay. Now. Talk to me, -9 plus 2. Good, -8 minus -4, circle agregado, -4. Right, circle agregado. 4 times -4.
-16.
Good, 5 squared. -5 squared.
-25.
-5 in parentheses squared. +25, good. -5 cubed. -125, very good. Simplify. Multiply coefficients, add exponents. 5 times -3 is -15, x to the 9th. Good. Next up, 24 divided by 3 is 8, x to the 5th. Then the y to the 3rd, so die. And then 2n to the 4th to the 3rd, what you need to remember here is that the cube refers to everything in the packages. The easy part, when I raise a power to a power, I multiply, that's n to the 12th. And then 2 to the 3rd is 8. So the correct answer is 8n to the 12th. Now, I heard some hesitation on number 7 before, so I want to go back and address that. -5 to the 3rd, because it's in parentheses, means -5 times -5 times -5. So 5 times 5 is 25, times 5 is 125. Now, I multiply by this negative, so this becomes a positive. Then I multiply by this negative, and it comes back to a negative again. One thing that we observe is when we do questions like this with the exponents, if the exponent is odd and it's in parentheses, it'll always be negative if the beginning number is negative. And if its beginning number is negative but the exponent's even, it'll be a positive, not a negative. Okay, any questions? All right, so let's talk about, I don't know what that was for. All right, let's talk about scientific notation. Actually, I think it's really easy. Let's talk about, who here is Italian?
I'm Italian.
Oh, we got the
Psych.
pan shooting up there.
Pizza.
Well, pizza is a good Italian food. I think someone said to me once it's really not Italian, but pasta, which I heard Marco Polo brought back from China. But suffice it to say that the Italians make the best food. Italians make amazing food.
I can speak Italian.
Me too. Mangia.
I don't know what that
Mangia means eat. Now, there's a very famous Italian guy by the name of Avogadro.
Oh, I thought his name was Andrea Pirlo.
Nope, Avogadro. That was his last name. You can tell, a lot of Italians have a last name that ends in a vowel. Avogadro. He was a really smart guy. He was a chemist. And he wanted to come up with a way to count the number of molecules in what they call 1 cubic meter at standard temperature and pressure. You don't really need to know too much about that, except to say it's a box about this big, okay? And he wanted to count the number of molecules in there, of air, and he did. I don't know how he did it, but he came up with a way of doing it.
Why does this last name sound like avocado?
Right? It does sound like it, but he is an Italian guy. And this is the number of, where's my pen? Here we go. This is the number of atoms, molecules, I'm sorry, depending on whether it's a compound or whether it's a single gas, like, say, hydrogen. This is the number of molecules in that one container. Again, the container is this would be this big, except it would be a meter in every direction. A meter is a little longer than a yard. This is the number of molecules. Are you ready? You're gonna write a lot.
Oh, lecture.
This is gonna be one of those really long equations.
Huh?
It's so satisfying.
Why is there like a 2 in the middle of this?
Like a 0, 0, the thing that says.
What number is that?
I have no clue.
Infinity.
That
Technically, this could be a 3. Okay. And I actually taught summer school this year.
Yeah,
And
you
when
have
I-
a cousin.
When I taught summer school, I was right across from the chemistry class. And she would constantly say to the kids, don't you know Avogadro's number? Don't you know a mole? And this is a mole, it's Avogadro's number. Yeah. Can you consider how many ways you can, imagine, I want you to imagine that you're like some kind of scientist for a minute, and you want to calculate, now that's just 1 cubic meter. In this room, there are about 4, 15, 12, 180. There's about 720 cubic meters in this room. And then, if you consider all the rooms in the school, plus all the stairways,
That's
probably like,
a million.
I don't know, 15,000, 20,000, maybe a million, I don't know, whatever it is. Bottom line is, if I wanted to figure out how many molecules there were in the school, I would then have to do times,
Hey, it's working now.
now, can you imagine doing this problem?
Yeah, it's got on the
Yes.
calculator.
Now, you would have
That's
all of
cheating.
these rows of zeros with just this little 6023 at the end. So Avogadro and a bunch of his famous math buddies,
Who's that?
they sat around, you wanted to go potty, you missed it, bud, you snooze, you
He's
lose.
an Italian.
Avocado.
But don't worry, you won't miss any for the next 8 weeks.
Huh.
So now, what you got going on here is Avogadro says there's gotta be a better way.
Guacamole.
He says there's no way in the world I have to, he says it's too big a number. It's just too much to do. He says, I gotta have a better way. Now, there are 2 things that you need to know about math people. Math people are brilliant,
Yeah,
Obviously.
Me.
Too smart for school.
very hard. And the second one you have to know is this. Math people
Or not stupid.
Jack, stop.
are lazy.
Yep.
I'm lazy, so am I a math person.
What math people like to do is find the easiest, most effective, quickest way to do something. Scientific notation is all about the quickest, easiest way to do something. I'm gonna multiply these 2 numbers, and I can do it just about as fast as that calculator in my head.
Really?
Yes. Don't tell me what the calculator says.
That's
2.6
more
minutes, 5,000.
Don't say a word.
6,600 times.
Shh.
What? The answer's blunt.
It's just about 9 times 10 to the 30th.
10 to the
I don't know,
30.
what does it say? It says 9.0345 times 10 to the 30th. And I just did that quick in my head. It took me less time to do that than it did for you to press those buttons.
Oh!
Now,
Oh, the brine.
Oh, the
The
burning
reason-
starts.
excuse me, scientific notation exists to make our life easier. It does not exist to make our life harder. Now, scientific notation takes something really big, long, and ugly and converts it to something manageable. Something pretty long and ugly and converts it to something manageable. Michael, head knee game. Put your knee down, face forward, turn your body. Now, what we want to do today is this. I want to teach you how to convert scientific notation to standard numeral and back and forth. I don't know that we're going to get 100% through the lesson, but I do know that we're going to spend the next 4 days after today talking about scientific notation and how to do it like I just did in my head, so that you'll be able to do that as well, which I do think you'll be able to do. Okay, so there is this table, and let's turn to that part of the page. And let's talk now about how to get things into scientific notation. Okay? This is what we would call standard form. In fact, I should write that up here.
One.
Standard form. And this would be called scientific notation. Okay. And I want to be able to convert back and forth between the two of them. Obviously, there are countries in this world where it pays to be able to talk more than one language. For instance, English is a language that's spoken in most European countries, okay? Kids learn it in school. Now, standard form and scientific notation are two languages for the same thing. Kind of like hola and hello, or aloha and hello, or shalom and hello.
Isn't aloha like different meanings, like goodbye and
I believe, well, I know shalom could be hello and goodbye. And aloha might also be hello and goodbye, but it does also mean hello. So anyway, here's standard form. 3,400,000. I'm going to show you what the answer is in scientific notation, and then show you how I got the answer. It's 3.4 times 10 to the 6. So write that down, and then let's talk about how I got that answer.
oh, stop
Okay?
talking.
It really is pretty easy. Now, everybody watching? Take your pen or your pencil, put it at the end of the 3,400. Now, all I'm going to do is move my decimal until I create a number between 1 and 10. Watch. 1, 2, 3, 4. If I stop there, that would be 340, wouldn't it?
Yes.
So I'm not between 1 and 10 yet. If I move one more place, that would be 34. Is 34 between 1 and 10?
No.
No, I gotta go one more place. And what number does that make? 3.4. That's where my 3.4 comes from.
Oh.
Then all I do is count the number of places I moved. 1, 2, 3, 4, 5, 6. And that's where my 6 comes from. So always you will have times 10, and then you gotta figure out what goes here and what goes here. But the times 10 never changes for scientific notation. Why don't you try the next one? Let's see how you do. Okay,
I said 7.5 times 7, to the 5th.
7.05 times 10 to the 5th. Very good.
Why does 7?
7.05 times 10 to the 5th. Now, let's show you where shoes came up with that answer.
Why is your nickname Shoes?
Oh, she knows. Ready? How many pairs do you have?
I think
30?
I have
Yeah.
13. No, I have 15.
And it's not just 30 pairs of shoes.
You're a
She
girl.
has different style points on these shoes.
She's a girl.
Shoes are very important.
I have 15 pairs of shoes.
You're a girl.
I'd rather not go there. Okay, so,
I have 10
ready?
shoes.
Check it out. Watch.
I wear socks.
Jared, here's the thing. I know you're not looking at it this way, but everything we do, it's like when you make a decision, you can never make one decision at a time. Jared, I want you to take your arm, stretch it out straight in front of you. Okay, stretch it out straight. And I want you to take these two fingers, put it right here. What's that muscle called?
A tricep?
Bicep.
Oh no, this is tricep.
Now, I want you to curl that muscle in. Feel it move?
Huh?
Good. Put it back there again. Now go underneath, and now you can feel the tricep. Feel that muscle move? Okay. It is impossible to move one muscle at a time. Totally impossible.
Oh, I guess I was paying
Muscles always work in 2 or 3 or 4s to get their job done. Decisions are like that. Whenever you make a decision, you make several other decisions at the same time. Now, I know that you're trying to be funny, and I like when kids try to be funny. Okay? I don't want you to be silent and sit there with your mouth shut all the time. But here's the problem. You gotta kind of begin to get a sense of, hey, is Mr. Lindquist driving at a point here? Is there something he wants everybody to understand? If that's the case, that's more important. Does that make sense? And if I'm not, crack the joke. Have a blast. And I don't expect you to be perfect at this. But if you get this feeling like every kid in the room is paying attention and everybody's trying to understand this, then you gotta let that happen, because at the end of the day, that's more important. All right? Okay, so, 7.05 times 10 to the fifth. Now, let's go through this one more time as to why it equals this. Remember, we start with the decimal here, and then I'm gonna move it until I create a number between 1 and 10. So if I only go 3 places, have I created a number between 1 and 10?
No.
Gotta keep going. So I go one more place. Have I created a number between 1 and 10? No, see, it's 70.5. 70 is not between 1 and 10. So I go one more place. Now I've created 7.05. Is that between 1 and 10? Yes, and that's why this is good, 7.05. Now I go back and I count the number of places I moved it. 1, 2, 3, 4, 5. 7.05 times 10 to the fifth. Everybody try the next one. Okay. Now, remember, start here, let's go. I'm gonna go as a group of 3. Can you all see that? Right, 3, then what? 3 more makes 6, 7, 8, 9. So what that tells me right away is that it's gonna be times 10 to the 9. Now, what number goes in front? Everybody?
7.2.
7.25,
That's right. 7.245. Okay? Good, try the next one. Remember, I gotta get a number greater than 1, less than 10, or equal to 1, less than 10. Ready? Here we go. 1, 2, 3, 4. 1 times 10 to the 4th. Agree? Yes?
Put 1.0 for that.
Yeah, that's fine. 1.0 is good too. All right, so now we're asked to go backwards. So I know I'm gonna start with 3 and 1, kind of like over here, but I gotta move a total of 3 places. Well, this was 1 place, 2, 3. So I go 3,100. Now, what I like to do is, when I think I have the answer, I look and I go backwards and see if it works. Would it work if I went backwards? 1, 2, 3. There's my 3, 3.1. Try the next one. Go ahead. One more. Did everybody get that as their answer? Right? Let's work backwards again. 3, 6, 7, 8. That's my exponent. I know what it is. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. These F-J's. Smile a lot. Ciao. Arrivederci. Adios, amigos. See you, amigas. Sayonara. Karushu. Kadafis. Hasta la lasagna. Thank you for saying today.
Oh, I get to have fun.
Hey, does anybody like ripe bananas? If you like a ripe banana, you can have it. Anybody want a ripe banana? It's yours. You want it, Mike? It's yours. Sure? I like it less ripe. That's all. I like kind of just yellow with no spots on it.
No.
All right.
I was thinking about it.
Have a good day, guys.
You should ask the coach now if the balls are downstairs, because it could be in the gym.
Are you going down there?
I'm not now.
No, I will see them tomorrow morning.
Okay.
And that's when I'll talk to them. I have to actually go to physical therapy in a minute. All right?